Okay. Our next speaker is James O'Brien. Dr. O'Brien is a Robert O. Lawton Distinguished Professor and Professor Emeritus of Meteorology and Oceanography at Florida State University, and retired director of its Center for Ocean Atmospheric Prediction Studies. So help me welcome James O'Brien.
Thank you very much. Thank you very much. In this talk, we're going to do a regional study. You might like to know that a lot of policy planners and so forth, yes? Okay, just hit the space button. A lot of policy planners are now telling the modelers that their current models have no validity for regional estimates of climate change, and that's a problem that needs to be worked at. In the Southeast, we have a huge El Nino, La Nina signal, which we've been taking advantage of to help agriculture and other sectors to take advantage of short-term climate predictions. What I'd like to do today is to tell you a little bit of what's actually happening about climate change in the Southeast. And so here's the picture that everybody shows. Al Gore says the sea level is going to rise 6 meters. I have never heard anybody who shows this picture, including myself, tell you when it's going to happen. And we'll come back to sea level rise, but I'll just make the comment that I've met elderly folks on the Jersey Shore, Virginia Shore, and the Florida Shore who live near the coast and are convinced by Al Gore their house is going to disappear before they die. This is a reconstruction from the GFDL model of what the temperature change is going to happen in 2100. This is for winter. The next one will be for summer. I'd like to point to where you can see Florida on the map. You will see that there's almost no projected change, although I don't believe the model at all because there's 2 grid points in Florida. Doesn't really represent what's going on. The other thing I'd like to point about these maps, you should be very upset about these maps when you see them. These are sort of a kind of a cylindrical projection because the volume of land in the high latitudes is greatly exaggerated. Again, in the summertime, you see that there's almost no change in Florida. Okay, so I want to talk about oranges, sea level, cooling in the Southeast, and I'll probably skip the hurricanes because I didn't time this talk very well, and what I have in there is fairly well known. The orange story. You should know that before 1835, the place that oranges were grown in the United States were coastal counties in South Carolina and in Georgia. And they weren't brought home to the home. They were used basically for go on board ships for scurvy. Then in 1835, this didn't come out. I fixed it, but I had sent this in earlier. They had 2 years of freezes, and they had to move further south. This is a wonderful picture that you see on the other side. Has anybody ever seen an orange tree that big? This is in St. Augustine, Florida. It's obviously that this is in 1890, that this tree has withstood decades and decades of growth without any really winter freezes. Although then it also had killing freezes, and they moved further south into Florida, and then moved even further south in the late 1800s. And then after the 1977 through 89, a lot of freezes. They're now near Lake Okeechobee, where they're not only threatened with greening and canker and hurricanes, but the land is a hell of a lot more valuable for you to live on. And so I predict if you look at what's going on with your normal oranges coming from Florida, you might not be surprised that Brazilian has passed Florida in terms of those kinds of oranges. And I predict in 50 years, you'll get your regular oranges from Brazil because the land is much more valuable. There'll still be a lot of citrus in Florida of other kinds. This is natural climate change, okay? Every now and then you have very, very cold situation that is in these trees. The sea level story, I mentioned this before. Here's the actual sea level rise at Key West and Pensacola, and I also have a 100-year graph from Jacksonville also. These are also, of course, hourly measurements in which the normal tides are removed, and you can see 0.27 millimeters is like 8 inches in 100 years. And yet, in Florida, whenever I hear anybody talk about climate change, they always mention sea level rise to scare people. It's a standard thing. And what I did for my governor, who's following Schwarzenegger in adopting climate change and lots of the things that go along with that in terms of, cap and trade and so forth, is I said, okay, let's say that instead of 20 feet sometime, how about 5 feet? Well, at the current rate, 5 feet is going to take 400 years. Let's double it. That'll take 240 years. 5 feet, if we quadruple the current rate, that'd take 141 years. I maintain that there's a bigger problem in Florida than sea level rise, and that is the fact is hurricanes and more people moving toward the coast. We need to do lots of other mitigation things there. This is the record. Some of you may not know that the sea level rise that's measured by tide gauges globally, everybody gets the same answer. But oceanographers put up instruments called altimeters that measure the sea level everywhere. They weren't put up for sea level rise, they're put up to measure ocean currents. But that little red thing on the end is the short record that comes from the altimeters, and there doesn't seem to be any acceleration of these found by anybody. People have looked, although the latest thing is that a satellite called GravSat has apparently indicated that the mass of Greenland is dropping precipitously, but I haven't seen a calculation about how much is that accelerating sea level rise. A year and a half ago, there was an article published on Antarctica which said the freshwater runoff from Antarctica had doubled, and one of us calculated that it's like a 0.5 millimeter a year. So the press is really, but let's go to temperature. The bottom line on temperature in Florida is that every rural station except one the temperature is dropping by about 2 degrees Fahrenheit to 1 degree centigrade in 100 years, and it's all anthropogenic. It has to do with the fact that in the last century, the farmers took all the wetlands and made it into farmland. And here's an example. This is the Funac Springs in the Panhandle. It's a small little town located near Eglin Air Force Base. And this is the annual average maximum temperature on the left and the annual average minimum temperature on the right. And the green line you see across there is the government's normal, which is a 30-year record. And so you can see the cooling that's occurred there. I don't really like, it is cooling on the average, but there's lots of decadal variability. Here's another station, Arcadia in the south. It's another small town. It hasn't changed much in 40 years. It's also cooling down. We need to get you to give us whether these stations are good stations or not. I have to check them to go home. And Fort Myers is in a city location, and of course we can see that the temperature there tends to be increasing. But there is an exception which I like from a science point of view. Belle Glade. Here, Belle Glade is here on the southeast side of Lake Okeechobee. And when I meet people in Florida and say, have you ever been to Belle Glade? And they've been through it. When they're out in the countryside, when you go into Belle Glade, what you see is sugarcane. Sugarcane everywhere. It's just like landing in Maui. If you haven't been to Maui and you land in Maui, the surprise is sugarcane every place you look. And sugarcane has a lot of moisture in the boundary layer, and so it keeps the temperatures up. And that's why we can see this increase here. Roger Pilkey Sr. has done a lot of things on land use changes to show that. I'm going to skip the hurricane story today and go to some other things. One of the things we did recently is to look at hundreds of stations east of the Mississippi, although I'm going to show you one in Phoenix, Arizona, too. We're trying to look for not just the average temperature change due to some change, but we're going to look at the whole range of temperature. Now, everything I show you is either going to be minimum temperature or maximum temperature. I abhor the metric that they use of average annual temperature, okay? Sometime ponder yourself about when did you experience last year? When? The average annual mean temperature. It's quite fleeting, okay? You don't give a damn about the average annual mean temperature, okay? This is a station in Orlando, and what you see here is a probability along the horizontal axis and time in the other, and I've done a little bit of one-to-one smoothing that takes out the year-to-year variability. So you can follow for each of the temperatures. Notice you see the wiggles, but basically if you start at the bottom and go to the top, the red line in the middle, you know, that's the mean annual minimum temperature, and you don't see any real trends in any of the temperature record. However, if we go to my favorite, which is Phoenix, Arizona, Phoenix, Arizona fits your thing, Anthony. Phoenix, Arizona used to be the poster child for global warming by all the other guys. Because they built an airport there in and around the 60s, and they and then it all built up. This is the annual minimum temperature at the airport, and the fact that these lines are sloping there, you can see that follow just the bottom is that there's about 6 degrees Fahrenheit change in the minimum temperature, and the story is that the mayor of Phoenix got worried about this. They still have a lot of desert to sell, okay? And, you know, the temperatures are going up too much in winter. These are the wintertime kind of temperatures, and so he decided to learn a little meteorology, and he did what Mr. Watts does. He went out and got an education about it. He found out that they had asphalt all around it. There was a little bit of grass. People were no chain link fenced, parking all around it, and so apparently he has gone out and fixed the situation a bit. And I understand, although I haven't done the latest things, is that now the annual mean temperature in Phoenix, Arizona is actually dropping because they've kind of fixed it up. But here's the other thing you should note. Here's the annual mean maximum temperature in Phoenix. There's no change, okay? Now get into your minds physically, if you learn a lot of meteorology and so forth, for most of mid-latitude-like places and the subtropical places, if we're going to get the warming that they're predicting, it's going to be in the minimum temperature, not the maximum temperature. The maximum temperature is controlled by other things, and that's why I think the metric is wrong. And this is Columbia, Georgia, which is there's no change at the airport there, and I'm going to go on. Now, I'm going to go. This is a very interesting study. I have a wonderful colleague. He's now 82 years of age. His name is Mort Ginsberg. He was a full professor of geography and did climatology in Florida, and he's retired, and I would give him money. Yeah, I got money from my grants. I get grants even though I'm one of you, okay? The fact this thing I don't get grants is nonsense, okay? I get grants, okay, but Mort loves to work with data. So he heard from the other guys that spring is coming earlier. So he decided to go find out in Florida whether spring is coming earlier, okay? So he had about 40 stations, daily records for at least 50 years, okay? And he painfully took a metric to find out spring is coming earlier. And I'll tell you the bottom line, and then we'll look at these graphs. The bottom line is, in every city in Florida, spring is coming a week earlier. And all the rural places in Florida, spring is coming later. This is all anthropogenetic, okay? In the cities, it's concrete, and the out thing is because they took away the wetlands. Okay? So this is man-made climate change, big time, but it has nothing to do with CO2. Now, if CO2 is affecting Florida, it's masked by this thing, because this is huge, okay? So what you see here is all down here in Miami and Fort Lauderdale and over on the other side and in Orlando, and a little bit in the Panhandle, the yellow colors, that's, I can read this for you. These kind of orange colors are that spring's coming 7 to 19 days earlier, and light green is six days earlier to 6 days later, so that's kind of mean. And then the blue means that the blue that's up in there is like a week to 3 weeks later. Now, I knew about the later stuff already. I knew about that because I deal with the farmers. That's what I do. I provide short-term climate forecasts for farmers through something called the Southeast Climate Consortium. And I knew the farmers were all planting later because a farmer doesn't measure, he doesn't go to your temperature thing to find out what you're planting. He measures in the soil to see what it is at some depth in the soil depending on what the crop is. So this is a very interesting study, in my view. And the end of the hot season, there's the blue areas is saying that end of the hot season is later, and he changed the color on me, and the red areas is almost no change. So in the farmland, the end of the hot season is not changing, but it's delayed in the city areas. And this is the length of the season, of the hot season. Okay, now, well, let me tell you another fact that it pisses off Jim Hansen, okay? But what Jim Hansen likes to do, he says there's going to be so much warming, and he comes down to Florida, he takes the probability distribution, let's say of Miami, Florida, right? And he moves the mean over by whatever he wants to move it over, 2 degrees, 3 degrees, 4 degrees, and then he shows how much of the tail of the hot weather, more hot weather you're going to get on the end, okay? Here's a fact for you all, okay? We have 100 years of daily records for Miami, Florida. Miami, Florida never had 100 degrees Fahrenheit, ever, okay? Why? Because of the sea breeze and everything, right? And then you sea breeze, you get rain, and you get ventilation and so forth. And it's a pretty good station. I'm going to have to really check on my stations after your talk, I'll tell you. Anytime. Yeah, anyway. Now, here's another, let me tell you another fact, of which it's amazing that other guys don't do this. When did we start weather observations in the United States? And we got a lot of bad ones, as we saw from Anthony here today. In the early 1800s, the Surgeon General of the Army was given responsibility for taking weather, and he took it very serious. So in our early part of our country, every time we had a fort, the surgeon at the fort was required to take minimum maximum temperature and precipitation every day. And these are all handwritten records, and now some people have gotten these records where they exist, and they're digitizing them and trying to fix them up. And the one I'm going to show you here, this is Charleston, South Carolina. The stuff that's here on the left, that's from about 1840 with some gaps into 1880, is that really warm stuff. And the other scatter diagram are other stations in the modern records, which are in the vicinity of this station. I have a hypothesis, which I'm going to try to work on with some of my students. The hypothesis is this: do we remember our stories about the Revolutionary War? When the rivers were all frozen in the Northeast? When Washington was trying to fight those, since I'm Irish, those bad guys, the Brits, remember? Okay? It was very cold. But apparently, my hypothesis is that in the next part of our century, here in the 1800s, remember we saw that orange tree that lived for a long, long time at St. Augustine, is that we actually had a warm period. This probably helped our country, increase, okay? Rather than going back and look at, what do they call them, beetle cones? The pine cones and things, or crystal, what are those things? Why don't we go back and look at some of this old data that's out there and see what was the temperature of our country back in the early 1800s? Okay, how does it compare with what it is today? And look at the metadata and look at the siting and things like that. It would be very, very interesting. But that's my hypothesis that if you believe this, and you shouldn't believe it, because you heard Anthony's talk, right? These are annual average minimum temperatures. Remember, I'm not going to show you maximum temperatures. But if you took sort of the average of this stuff in the modern era, or you say it was about 5 degrees Fahrenheit warmer back in the middle 1800s than it is now. Unfortunately, when you put in the Charleston City, it agrees with it pretty well. Well, here we have, if you just look at the brown line and the forts data, that my hypothesis is in trouble, because it looks like if you take the station that's closest to where this old data was, it's going through 2006 here, okay? This is average minimum temperature. There's really no huge change going on in this record. So what I've tried to do today is tell you about what's happening in my state of Florida.